they'll take you on a fairly good simulated profile and give you almost a real experience with the real G-forces, because they're very advanced machines that do the simulation. The second step, and I'm sure all of you would like to do this, I hope so. How many want to go into weightlessness on this A300 0G? Excellent. I'm sorry, but I don't have any ticket free passes. I'm still waiting for my trip. I've done a medical exam, and now I'm waiting for the A300. I'm waiting to be a test subject, so I don't have to pay for it myself. So what's happening with that? We think that this is an essential step because this gives you the experience, the feeling of what it's like to float in zero gravity. There's two reasons for that. Well, the main reason is just to make sure that you and your body, you know what you're going to feel when you go onto a suborbital spacecraft like the Lynx. That you're prepared for the sensations, the physical, the emotional sensations of being weightless, so that when you fly to space, you can actually enjoy the view out into space rather than panicking about what's happening to your body. The final step is a full simulation with a jet fighter, a trainer, to take you from the runway and kind of do a simulated profile with a zero-G parabola at the top, just to give you the full sequence of takeoff, high Gs, zero-G, and then high Gs again as you pull out, to give you the full sequence of how that will feel when you go into space. Let's see what Brian Binney experienced when he flew Spaceship One. This will give you a really good idea of the G-forces people are expecting. You just got slammed back in the seat as it went from 0 Gs in that direction to about 3 or 4 Gs. So it's taking a lot of concentration, a lot of physical effort to control his own muscles as he's piloting the spacecraft. What I think is what's magnificent is the view. And the Lynx gives you a great view from space. And here on some of the video, you can see the view that these guys have when they're flying Spaceship One. And here we're going to come up to a little bit of technical problems that I think is really good for students to look at, so that you can know what you have to do to address them. This is called vibration. So, why is it happening? That's what you might ask. Well, in the hybrid engine, that actually happens towards the end of the burn when your oxidizer tank is getting low, and you start to get some cavitation in your pellet flow. So I'm hoping that Virgin actually designs that out of Spaceship Two, so that the space tourists can enjoy it rather than being shaken up like a cocktail. This is the view that everybody wants to see when they go up. And that's over California, on the Pacific coast in the United States. So they're seeing Mojave Desert down there. I actually think Mojave is a better spot to launch from than New Mexico, because in Mojave you get to see the oceans, you get to see a little bit of contrast between the ocean, the coastline, the mountains, whereas in New Mexico, where we're planning to launch a Virgin, it's actually quite flat, and you can't really see any of the ocean around there. At Cosmic Space Lines, our fundamental vision is to bring a Lynx to Europe and to actually have real suborbital spaceflight operating here in Europe, because we think that it's good to be close to researchers, it's good to be close to our clients, the potential astronauts, and so that's what we really want to do. We want to bring everyone here, bring a Lynx here, so that we can fly out of one of the European countries, preferably along the Mediterranean, because it's got good weather most of the year, which helps facilitate flying. We also offer space travel experiences like training. We can offer the jet fighter training, the centrifuge, through SXC, Space Experience Corporation, out of the Netherlands and our partners. So those can be done in advance before booking a ticket or as part of a ticket package. We also offer research and technology flights, and that's one of the reasons I'm here, is to hopefully convince you that as a student project, You could do a research, like a CubeSat type project, not launch it into space for orbital flights, but launch it up on a suborbital flight. And so please grab one of these brochures, take it home with you, share it around with your friends, and see if you guys can get something going on the science and technology side. You know, that kind of thing will take place over the course of a year, and you can fly it at the end of the year. The other thing we want to do is offer a space plane, a joint ownership of a space plane, as a laboratory equipment. So why not having SouPaRL own 1/10 of a Lynx? Convince your professors of that. I'll be happy to talk to them. Where we think that private owners will also want that. So Cosmic has been founded in July 2010, and we've been under development since 2005. It's a long process. If you ever do start a company, the one thing I recommend for you is just stick with it. Persistence is key to making it a success. So good ideas are great, but if you don't have the persistence to see it through to the end, it's not going to go very far. So just make sure that you know you're in for the long haul. And this is what X-Corps Aerospace has done. They were founded in 1999. It's now, 14 years later. They're still in business. They still haven't seen any of their vehicles in space. But 14 years is the time it's taken for them to design multiple generations of rocket engines, to test them. They've had over 5,000 firings of the rocket engines. They've made sure that the safety aspects are there, so it's safe to fly on a vehicle with humans on board. They've got 2 generations of rocket-powered airplanes, the Easy Rocket and the X-Racer. I'll show you a video of one of those a little later. They've been funded by angel investors in the beginning. They've been funded out of their own pocket as well. And they now have revenue-generating contracts from bigger aerospace companies as well as from some government institutions. So they're going to be around still for a long time. Now, the Lynx Mark II spaceplane. This is a little bit of an older version. The outer mold line is a little bit more like that one, so the shape has changed a little bit. But it's really the size of a small business jet aircraft. There's room for 2 occupants, the pilot and the passenger. It's got pretty incredible performance because it goes from 0 to Mach 3, Mach 4 in a little under 2 minutes. So it's all the other details are there. What X-Corps is doing is designing it as an airplane where you can operate it and fly it multiple times a day. Their target is 4 times a day. They may possibly be able to get it up to 6, 8 times a day if the operational concept proves itself out to be able to do it. All you have to do is put kerosene and oxygen back in to get it to fly again. And the reusability of the engines is really key, where they can go 40 to 50 flights between an engine maintenance, preventive maintenance, so they don't have to take an engine out and put a new one in like a space shuttle every time. This gives you a good idea of the manufacturing, the components that are built in. The blue section is the cabin, where you have the 2 occupants. That's the pressurized zone. Otherwise, it's very much like an airplane. Behind the cabin, you have the oxygen tank. So that would be cabin in a normal aircraft. You've got the wing strakes with the fuel, the kerosene in it. You've got leading edges that are going to be seeing the heat of re-entry. It's not a huge heat, not like an orbital spacecraft, so they don't need advanced materials on it, but they're still having some, the Covar over silica. And the Lynx is actually manually piloted. There is no computer between the pilot's hand and feet and the flight controls. They will be boosted, so I believe I don't know if it is electric boosting on the flight controls, but as he's pushing, that force is going directly back to the flight controls. That's why it has this shape where it's a fairly stable shape throughout the subsonic, transonic, and supersonic flight regimes. It's a very high-performance glider. And so why did I choose X-Corps as a partner? Well, in the space tourism industry, a lot of people throw out PowerPoint presentations. Mine's a PowerPoint presentation. I've got lots of graphics that are, renderings. There's not a lot of real photos. But the thing about Xcore is they do have real hardware. They have real things that are being built and tested today. And whenever you're working on an aerospace project, hardware is a measure of how valid the project is. It means that they're able to get funding, they're able to actually go out and design things, manufacture them, test them, and learn from that process. There's a cockpit mock-up. They've got the piston pumps. The piston pumps are unique because typically we use turbo pumps, which spinning rotational pumps, but those have high energy levels. A piston pump is much safer. It's kind of like an internal combustion engine, but it's going to pump the oxygen and the kerosene into the engine chamber to raise the pressure of the propellant feeds. And what that means is that their oxygen tank and their kerosene tanks, they don't have to be under high pressure. They don't have to have helium pressurization in the propellant. This is the profile. You can see the different flight phases where you take off from the runway, you're at about a 70-degree angle as you're going up into space. The engine's off at 60 kilometers roughly. You have 4 minutes of microgravity. And then as you re-enter, you're going to re-enter in flat, slowly nose down, and then you have a pull out where you get the high G-forces. And then you have a 20-minute glide back to the base where you took off from, back to the same airport. Let's go take a spin. The guy in the right seat on that animation is Per Wilson. He's an adventurer and a finance guy. He's based in London, and he's going to be the first person to fly as a passenger.
Going straight up, the TP element, things happen in Earth, that altitude, putting them on 78,000 feet, the sky starts to turn dark by 100,000 feet from flying. Once we get to Maine to cut off, we'll have a brief period of weightlessness, we'll kind of go. And then you have several minutes to enjoy the view, and enjoy the result and sensation of the view on the board. The opportunity to maneuver using the reaction control system, turn it upside down, and take different attitudes, and just hold there. You're going to get spectacular view. Be able to see out to the Grand Canyon, all the way down Baja, California, looking out to the sun on the Pacific Ocean, and then from there it's just a long line back home. So it's looking at the Earth. It's virtually life-changing. Really the key driver to what will make this experience so special.
So now who wants to go? I definitely want to go. I can't wait to get a chance to go on the links. You have a chance to go actually. If you go to Axe Apollo, if you do a Google search for Axe Apollo, you will find that you can enter into a contest, and if you're good at managing a social media network and getting your friends and your friends' friends to boost you in ratings, you could potentially be a candidate to go up on a links flight. So Unilever bought 22 flights for that promotion, and so it depends on which country you're from. You can compete against other people to try to get a free flight. But I think it'll take a lot of work to work the network on that. So how many suborbital programs and astronauts have we seen so far? We saw 550. I think I already told you a little bit. There's not nearly as many. So this is what's really surprising. We have basically 4 different programs that have resulted in suborbital astronauts. The first one was the Mercury program. where Shepard and Grissom